Good morning everyone. So in the last class we have talked about Fourier coefficient and Fourier series. In today's class we will discuss the convergence of the Fourier series. It means that you will see the condition under which the Fourier series for the given function f of x not only converges but it converges to f of x. So for this we will discuss the Dirichlet condition for the convergence. Now the Dirichlet condition for the convergence says that if the given function has finite number of the discontinuities, let's assume that. Now at the point of the continuity, let's say x naught, f of x is continuous at x naught. So in that case the left hand limit f of x naught plus right hand limit would be equal to left hand limit, and they would be equal to the value of the function at the point x naught. In that case I can say that f of x naught can be written as f of x naught plus f of x naught minus by 2. It means at all the point of the continuity the function, the value of the function would be f of x naught, which would be equal to f of x naught plus f of x naught minus by 2. It means that at the point of discontinuity, if I redefine the function, or if I define the value of the function as f of x naught plus f of x naught minus by 2, then at all the points, at the point of continuity also and at the point of discontinuity also, the Fourier series would converge to the function f of x. So this is what is given by the Dirichlet condition. So it says that let f of x be a function defined and bounded over the interval minus pi to pi, and it has finite number of discontinuities and only a finite number of maxima and minima. Now we assume, since the function f of x is periodic, so that's why we assume that f of x plus 2y is equal to f of x for the other values of x other than minus pi to pi, because it is defined over minus pi to pi. Now especially when I have to compute the right hand limit, for example I want to compute the right hand limit at x is equal to pi, then I need limit h tends to 0 f of pi plus h. So that's why I assume that the function remains periodic. If it is like, for example, till 0 to pi, this is how it is defined, and minus pi to 0 it is 0 and then it is x. Then if I have to extend it, it will remain like this, 0 and then this, 0 and then this. Similarly, it can be extended on the left hand side. So this is why I assume the function to be periodic. And now the Fourier series of f of x converges to half f of x plus f of x minus at every point of continuity of f of x. So now if at every point of discontinuity, if we redefine the function as half f of x plus f of x minus, which is the right hand limit and the left hand limit. So this is the right hand limit and this is left hand limit. Then Fourier series represent the function everywhere. This is what has been stated by Dirichlet condition of convergence. It would be clear once we see an example which says that find the Fourier series for the given function and show that pi square by 8 is equal to 1 plus 1 by 3 square and so on. Okay. So Fourier series we have already discussed in the last class, so that's why it's not difficult. I suggest that you must try it by yourself. So a naught comes out to be pi by 2 because the function is defined from 0 to pi only and it is x. From minus pi to 0 it is 0. Similarly, you can compute an, where you will find that a to n is 0 and a to n minus 1 is minus 2 by pi to n minus 1 whole square, and compute the value of bn, that gives you the required Fourier series. Yes, now I need to identify the point of the discontinuity. So of course, if you draw the function, so this is how the function is defined. So if you draw it, then this is how it looks like. So clearly at x is equal to pi and x is equal to minus pi, they are the point of the discontinuity. So at the point of the discontinuity, I can use the Dirichlet condition. These are the jump discontinuity. It is clearly visible. So let's assume at x is equal to pi. So I say that using Dirichlet theorem, at point of discontinuity x is equal to pi, the series converges to half f of pi minus plus f of pi plus. So now let's compute what is f of pi plus. So f of pi plus means limit h tends to 0 and f of pi plus h. Now somewhere after pi I have pi plus h, so which is 0. Similarly, if I compute f of pi minus, then it is limit h tends to 0 f of pi minus h, which is limit h tends to 0. Pi minus h is just before pi, so which is pi minus h, and this becomes pi. Yes, so it means that the left hand limit is pi, the right hand limit is 0, and at the point x is equal to pi, f of pi becomes pi plus 0 by 2, which is pi by 2. Now in the Fourier series, I replace x by pi. So when I replace x by pi, then sin n pi is always 0. Yes. So sin n pi is always 0 and cos 2n minus 1 pi. So it means I have only odd values. So I will get minus 1, then plus 1, and sorry, I will always get minus 1 because cos pi is minus 1, cos 3 pi is minus 1, and so on. So if I substitute the values, then cos 2n minus 1 pi is minus 1. So minus minus will become plus. That's why it becomes 2 by pi. If I take pi by 4 on that side, then pi by 2 minus pi by 4 is pi by 4. And the summation 1 by 2n minus 1 whole square would be 1 plus 1 by 3 square, and so on. So if I take 2 by pi on that side, on the left hand side, then I will get pi square by 8 as the sum of the series 1 plus 1 by 3 square, and so on. So this is how I have used the Dirichlet condition. Let's try one more question which says that first find the Fourier series, and once you have the Fourier series, then sketch graph of sum of this series for minus 5 pi to 5 pi and find what numerical sums are implied by convergence behavior at the point of discontinuity x is equal to 0 and at x is equal to pi. Okay, so again Fourier series, please spend some time and try to find it by yourself, and then you can verify with the answer which is given in the notes. So this is my required Fourier series which has sine terms and the cosine terms. Now at both x is equal to 0 and x is equal to pi, sine terms would be 0. So I will only have the cosine terms. Now if I draw the graph, then this is how it looks like. Now it can be observed that at x is equal to pi also I have jump discontinuity. At x is equal to 0 I have jump discontinuity. At x is equal to minus pi I have jump discontinuity. So if I compute the left hand limit, which is f of pi minus, then limit h tends to 0 and f of pi minus h. So pi minus h, so it is given x, which is gives you pi, and f of pi plus is limit h tends to 0 f of pi plus h, which becomes minus pi. Yes, after pi plus h I have a constant function minus pi. If I add them, then it comes out to be 0. Similarly at 0 if I find, so f of 0 minus is limit h tends to 0 and f of 0 minus h. So 0 minus h is minus pi. If I see here, this is 0, so 0 minus h, and similarly f of 0 plus h is 0. If I add them and divide by 2, it becomes minus pi by 2. So now you can observe that f of x, this is how it looks like, and f of x, we got this value to be equal to 0. So half minus pi plus pi, which is 0. Now I substitute into the series. So as we have seen it that sine pi is 0 and cos 2 and minus 1 pi is minus 1, and that's why I will get the following sum: pi square by 8 is equal to summation n and 1 by 2n minus 1 whole square. Similarly, at x is equal to 0, we have just computed that it becomes half and minus pi plus 0, so that's why minus pi by 2. I substitute the required values and I will have the sum which I am looking for. So that's all from Dirichlet condition. In the next class, we will introduce the concept of Fourier sine series and Fourier cosine series. Thank you.